𝗦𝘂𝗽𝗽𝗀. Welcome to another episode of the 𝗦𝘂𝗽𝗀 podcast. Our goal as students is to strengthen these synapses to make our memories solid and strong so that you don't lose. Because our goal is to not forget, even though our brains are basically programmed to forget stuff that are not important, that we don't recall. I mean, that's just basic human physiology and that's how it works. We all complain about forgetting stuff, but it's a good thing that we forget things. If you don't forget everything that goes into your head, that's going to be a bigger problem. There is also a type of obsessive compulsive disorder that often gets confused with photographic memory. It's a disorder where the person actually obsesses over their memories. The patient is actually obsessing, thinking over and over again about, especially this happens with episodic memories with the OCD patients of this type. They obsess over those memories, those events in their head. So they remember every event that has happened in their life, every single event with the date and time. And you can, unlike people with photographic memory, these are like very emotionally charged people and they obsess over their memories and they're kind of emotionally still involved in those memories. Every bad thing that happened to them, they're still offended, they're still thinking about it and obsessing over it. So that kind of ability to remember is not worth it, trust me. You'd rather forget stuff than be that person. And back to the topic, long-term potentiation. This is the thing that we should achieve in our synapses to achieve long-term memory. Even this, if this happens too much, this can cause long-term depression apparently. But I hope I didn't get too technical in this topic, and I hope you guys got a rough idea and a good recall of your neurophysiology. So the main thing that I want you to get into your head is that it's important that you study, like most of the stuff as medical students especially, most of the stuff that we need to study are explicit memories, stuff that are in nature explicit memories. And what I want you to know is that it doesn't always have to be stored in your brain as an explicit memory. It can be associated with your emotions, an episode, and like an event. It can be associated with another explicit memory, or it can be associated with names, facts, and something that happened in the day or something that happened in your lecture. If something interesting happens in your lecture that is unrelated to the topic, you're still more likely to remember that the subject material that happened in that lecture rather than a boring lecture. So that's a tip for your lecturers. Try to excuse your students for being a bit more interesting during lectures, because they're actually helping the other students retain more of what you just taught in the lecture. The more smoothly your lecture goes, the less of that will be remembered by your students. And the other thing that I want to get to you is that you need to be able to differentiate between which of the things that you are learning have to be implicit and explicit memories. And the way you need to approach these things are different. For example, let's say you have an anatomy topic, which is obviously explicit memory. So just reading through that anatomy page, book or whatever, this happens to all of us, right? We are just reading through and we finish an entire paragraph and then we just realize, wait, what? None of that went into our head, right? So you need to be like very awake and like consciously paying attention to the task at hand when we are learning something that is going to be an explicit memory. But when it comes to implicit memories, your goal is to be able to do it without paying attention to it. So it doesn't matter whether you're paying attention to it or not. I mean, I guess the first few times you have to because you haven't exactly learned it. But something like riding a bicycle, you have to pay attention to it in the beginning to get used to it. But it doesn't have to continue like that. You don't have to pay attention to it. It has to come automatically and you're supposed to let that happen. This applies to our context when we do stuff like skills that we need to acquire as students. That involves getting used to doing question papers, getting more familiar with the type of exam questions that you're going to get in your exam, and other things that may help in your studies like your typing speed. Those are not things that if you want to increase your typing speed, like paying full attention to your keyboard and trying to type that's not gonna work. You're supposed to basically just do it more and more often and try to make it a more natural process. And the third thing is about active recall. Yep, that's what I was trying to get at the whole time. So as we learned, these memories are stored in our brain in the synapses. And the way to make these memories retain in your brain is to stimulate those synapses in a certain way that it retains in your brain for a longer time. So, as I said earlier, what we need to really achieve is that long-term potentiation, the one that involves protein synthesis and the phosphorylation of the AMPA receptors. This is the one that actually stimulates long-term memories, the formation of long-term memories. So, in long-term potentiation, it's a persistent strengthening of the synapse based on recent patterns of activity. It's different from the post-tetanic potentiation that I talked about, and this is what really causes the long-term memory formation, according to a lot of research done in this area. I will include the research that I talked about in the description. So it's really hard to incorporate these findings in the cellular level into real life phenomenon, but there have been a bunch of research done on this, and not on humans but mostly on mice, but that's as good as it gets, so we're gonna have to live with that. So they have found that this is especially involved in the formation of spatial memory, which is very relevant to us medical students because spatial memory, like anatomy, is basically 50% spatial memory. So, and it's also involved in inhibitory avoidance and behavioral learning. So in the spatial memory experiment, let me tell you a little bit about that. The scientists gave these mice drugs that enhanced the long-term memory potentiation, and those mice performed better in learning their spatial memory, learning the area around them, much quicker and much more efficiently than the mice who weren't given that pharmacological enhancement. So, like I said, the long-term depression that I talked about earlier, I was afraid that you might get it wrong. The long-term depression is not like the clinical depression that we talk about. Long-term depression, what I meant by that was the neurological effect, the opposite of long-term potentiation. It's the activity that causes a decrease in the synaptic strength, which is the opposite of long-term potentiation. And when this says persistent strengthening, and this is where spaced repetition comes in. So let me tell you a bit about spaced repetition if you don't already know. This is very popular among medical students, right? So if you don't know about spaced repetition already, please let me introduce you to spaced repetition. Spaced repetition is basically an evidence-based learning technique. I don't know why this is not more widely used and incorporated into our learning, and this should be. And this is widely known among medical students, but this is not something that was taught to them in medical school. It just passes down onto them from the seniors, I guess, and through social media and other internet platforms. Spaced repetition is an evidence-based learning technique that is usually performed with flashcards. We need to stimulate those neurons, right, in a persistent manner. And spaced repetition is basically, they have, through experiment, found the best way to induce this long-term memory formation, the best and most efficient way to recall, the best way to turn these short-term memories into long-term memories is, like we said, to stimulate those neurons. That means to recall those memories. And the way to do that is to make that long-term potentiation and then recall the memories. Not just learn it all over again, but actively recall it. So in spaced repetition, something that we come across is active recall. So it's basically not just like looking at the note that you wanted to study again for the second time, but like actually trying to recall it without any source, trying to recall it from your head, and then check it with an actual reference to see if you are right. This was first introduced by this guy named 𝗦𝗽cije𝗁𝗂𝗃, a German psychologist. And there was another guy called Sebastian Leitner, and he introduced the Leitner system of flashcards with the lightness box. I'm not sure if I should go through all of these in this podcast. That's a lot of information for you to handle, but this is going to be a longer one. So Hermann Ebbinghaus, what he did was he introduced the forgetting curve and how that forgetting curve could be reset with repetition based on active recall. I have explained this beautifully in one of my YouTube videos titled The Best Learning Technique in the 21st Century. And it shows how the forgetting curve kind of resets when you do an active recall. And in the way you space these active recalls, you can increase your efficiency of learning significantly. So this spaced repetition is done using flashcards, right? So, and another thing you need to know about spaced repetition is this theory works only for memories like semantic memories which are not associated with other memories. For example, like one single fact, like let's say in reality when you are learning something in a subject, all those facts that you learn are usually correlated with each other. Like for example, even in anatomy, okay, you learn about the liver and then its relations. So it has an aspect of understanding it as well. And even though you don't remember the exact fact, sometimes you are able to work it out with the other facts that you do know. So this theory mainly applies for, like, this is basically only tested on independent facts like names and places that are not related to other things. And this method can be directly applied when you are learning a language. And even still, those words, the new vocabulary you learn, the words, you can incorporate it into different things. And when you do that, the rate at which you forget changes for the type of memory that you are trying to learn. So it's not always the same in the forgetting curve when there are other factors involved, and you need to be aware of that. But still, you need to apply this method into your learning regardless, because literally every medical student in the Western world uses this. Even I discovered this learning method online, and I have been using it ever since. And in the time I did do spaced repetition properly, my marks were pretty satisfactory. And that's it for today's podcast. And I wish you all the best in your studies. Senpai out.
Net motivation.